I want to store employee and department information inside of a SQL Server database, and to access SQL Server, I'll be using the Entity Framework version 5. If I look at the list of installed packages in a brand new ASP.NET MVC4 Internet application, I will see Entity Framework was added to this project by default. This is version 5 of the Entity Framework, currently in pre-release, but that should be finalized soon. And I want to access the SQL Server through the Entity Framework using this abstraction that I defined earlier, iDepartment Data Source. That will give me access to employees and will give me access to departments. And I just noticed that this property name is wrong. I shouldn't be naming this type. I should be naming this employees. So I'll make that quick correction and do a build to make sure everything compiles. And then, since I need this interface definition in my web project, I will add a reference to that project. So right-click, add reference, go to the reference manager, select emanager.domain, click OK, and now emanager domain is a reference in my web application, and that means I should have access to that type. Let me create a folder in the web application called infrastructure. This is where I will put all of the real data access code that talks to SQL Server through the Entity Framework, and it's inside of here where I will add a class, and let's call it Department DB. I want Department DB to be derived from an Entity Framework base class called DB Context that takes care of all the data access stuff that I need. I never have to worry about a SQL connection or SQL parameter or anything like that. And I also want it to implement the iDepartment data source interface that I defined earlier, because I don't want my controllers to know about Department DB directly. I want them to do data access through this interface definition. That just makes the controllers a little more testable. We're not going to go into the unit tests in this module, but also makes them a little more decoupled and flexible. For the Entity Framework to access my employee information, I will need to define properties of type dbSet. dbSet is a type defined by the Entity Framework. It basically derives from iQueryable and iEnumerable ultimately. But we'll have those there so the Entity Framework can get to employees and departments. That's also, dbSet also provides functionality for adding and removing employees and departments. The next thing I'll do is implement this iDepartment data source interface, because it defined employees and departments also, but it defined them as type iQueryable of employee. What I can do is I can tell Visual Studio to explicitly implement this interface. That gives me a version of employees that returns iQueryable, that satisfies the contract for iDepartment data source. And when someone calls the employees property through that interface definition, I can just return employees the dbSet type. And let's do that for employees. Let's do that for departments. And believe it or not, this is almost everything that I need to be able to start accessing SQL Server. In fact, this is just about everything that I need to create a database in SQL Server, because the Entity Framework version 5 has what we call code-based migrations, where it can simply look at your DB context class, see what DB sets are available, look at the definition of employee, look at the definition of department, and generate a SQL Server schema from those type definitions. Let me show you how that works. I'm going to open up the Package Manager console, so the NuGet Package Manager console. Make sure my web project is selected, and tell the Entity Framework that I want to enable migrations in this project. What this will do is create a migrations folder for me in Solution Explorer and add a class called configuration.cs. That's what we see on the screen here. And I'm going to enable a feature known as automatic migrations. Automatic migrations are great when you're a solo developer or working on a small team or just getting started on a project. Essentially what they allow you to do is quickly make changes to your database and keep it in sync with what is in your code without adding any additional code into your solution. If you're in a situation where you need a little more process or you have a DBA involved, you might not be able to use automatic migrations, but they're going to suit our purposes just great. I'll show you how the migrations work here in just a second, but I'll also tell you right now that when a migration runs, that is when you create a database from your C# type definitions, or you change your C# classes and you need to make schema adjustments to accommodate those changes, there is a seed method on this configuration class that can run each and every time that happens. And seed allows you to initially populate the database with some information. So every application typically has some sort of lookup table or multiple lookup tables that contain static data, things like a list of countries or a list of postal codes. It's the seed method where you can make sure your database is initially set up with that information. And let's say that I initially want to seed the database with some departments, just to make sure they're in there right from the very beginning. Then I can say context.departments.add or update. This is a method that you really only use during the seeding phase of a migration. It tells the entity framework, take this department and either add it immediately, or if it already exists, then update it. Since we do not know what the ID of a department is at this point, SQL Server is going to manage those IDs, then I can tell the entity framework to look at the name property of a department, and if it doesn't find that name, then add a department. If it does find the name, then update it. So let's create some departments. I want a department for engineering. I want a department, I guess we could have a sales department. If we have sales, then maybe we also need a shipping department. And of course, every company needs the good old human resources department. So now, every time I make a change to the database, a schema change to the database, or create a database with the entity framework, it should make sure that those 4 departments exist in the database. Let's create the database. I'll go back to the Package Manager console, and now I can type update database. And you might say, well, which database? Well, the entity framework will use some conventions to go out, and if it doesn't find a database by a particular name, it's just going to create it. And you can see here that it automatically applied a migration to it. That migration should have had all the DDL statements needed to create tables and foreign key relationships and primary keys to store my departments and my employees. And where does it go? By default, in Visual Studio 2010, it would look for SQL Server Express running. And it would just go up to SQL Express on the local machine and create a database that has the same name as your DB context derived class. So if my DB context derived class is called Department DB, I should find that database in SQL Express. In Visual Studio 2012, it's a very similar story, but by default, the entity framework will use LocalDB. LocalDB is the new version of SQL Express, and it will place the database in a folder called App Data. I'll go here in Solution Explorer and say, show me all files. Now I can see that there's a Department DB database in this folder, so that matches the name, including the namespace of my DB context derived class. I can actually double click that to open it up in Server Explorer. And if I go into tables, I can see there's departments and there's employees. My employees have an ID column, a name column, a department ID, foreign key column. All of that was just created based on my C# type definitions. The entity framework looked at them, figured out what sort of database it would need to store that information. Now, if I want a little more control over where this database is created, what server it's going to, what the name of the database is, I can just tell the entity framework to use a particular connection string. And that's actually something I'm going to do right now. I'm going to delete this database. Make sure that it's removed from app data. And then in my Department DB class, I'm going to add a constructor. When it calls the base class constructor of DB context, one of the parameters I can pass here is an explicit connection string or the name of a connection string. So I'm going to tell it to use default connection. Because if I look in web.config, a default connection has already been created for me by the new MVC4 project template. Default connection in Visual Studio 2012 will just go to localDB. It will create a database called emanager.web. In fact, let's fix this up a little bit. So it's just emanager. .web is the database name in a file that is the data directory. And I can also modify this name also. I could say this should be emanager.mdf. And I wanted to make all these changes because this default connection string is going to be used both by me and my department DB to access employees and departments. But later we will add the ability to let a user log in and register and restrict some of these features to only admins. I want that membership and role information to also be stored in the same database, and ASP.NET has features that will automatically do that for me, but they will need to know the name of a connection string to reach a database. So now everything is in place, or if I do a build, we're still building, and if I open up the package manager again, I should be able to come out and do an update database. And this time let me add the -verbose flag, and that will show you all of the commands that are being sent to SQL Server. So you can see there are indexes being created, tables being added, and also a table called migration history that will contain all of the information about migrations that have operated on this database. And with that in place, let's go into app data again, and let's show all files and do a refresh to see we now have emanager.mdf, just like I specified in the connection string. And if I open that up, again, we have departments, we have employees. Employees have all the right properties. I can show the data that's in the department table, and hopefully we'll find our 4 departments that we created during the seed method. And there we have engineering, sales, shipping, and human resources. Great. Now let's see if we can get that information into a browser. Now that I have my database set up, I want the home controller to be able to get a list of all the departments in that database and hand it off to a view to render. The simplest possible way to do that would be in the index action of my home controller, look at the department property of an iDepartment data source, that's all the departments that are available, and simply take that value and pass it off to the view. There's another overload of the view method where you pass in the model for the view to render. At that point, the view should be able to grab that object, loop through the departments, and build some HTML so the user can see all of the departments that are in the database. The one catch here is that initially I wanted the controller to only know about iDepartment data source. That makes things a little more testable and a little more flexible. But right now it is explicitly creating an iDepartment data source by instantiating a department DB. That's the class that we just derived from DB context that uses the entity framework. This is easy enough to fix up. If I truly just want the home controller to only know about iDepartment data source, then I would remove that hard-coded dependency and define a constructor where I say, if you're going to create me, what you need to do is pass in the iDepartment data source that you want me to use, and I'll assign that to a private field. Now my home controller knows nothing about department DBs. The one hitch to this is if I hit Control F5 to build and run this application, is that the MVC runtime doesn't know how to create a controller that doesn't have a default constructor. A default constructor is a constructor that doesn't have any parameters. It's parameterless. That, fortunately, is a very easy problem to fix. What I just need to do is plug in some additional components into the MVC runtime that can create that controller for me. And there's several of these components out there. They're typically known as inversion of control containers. There's one called Ninject. Microsoft has one called Unity. I'm going to go out and look for one called Structure Map, and I'm going to look for the MVC3 version of Structure Map. It still works with MVC4, they just haven't updated the explicit name here to say MVC4. I'm going to select that particular NuGet package, say please install this. That's going to add some code-based configuration files and assembly references into my project. I just need to find one particular file that should be under the dependency resolution folder. It's called ioc.cs, and this basically configures structure map. I'm not going to spend a lot of time on dependency injection or what this is actually doing, but if you look at this code, what I'm going to say is that when you see something that needs an iDepartment data source, then the concrete type that I want you to put into that component is a department DB, that type. And now structure map plugs into the ASP.NET MVC runtime. When the MVC runtime sees that it needs to create home controller, it relies on structure map. It says, dear structure map, do you know how to create one of these? The structure map will look at this and say, oh, I need to call this controller, but I need something that implements this interface. Fortunately, someone has configured department DB to be used as an iDepartment data source. So I'll just create that controller for you, pass along this object, and everything will work just fine. The only other thing that I'm going to add here is a method that tells structure map to scope this to a particular HTTP request. And now I have everything for this to work except for the view. At this point, we have a view, but it doesn't know anything about departments. And instead of using this existing view, let me show you a quick way to do this. I can right-click inside of this method and say add a view, and I'll get this add view dialog that can create things for me pretty quickly. This is what we call scaffolding in ASP.NET MVC. It's the scaffolding that builds out things for you. I can say I want a strongly typed view. That is a view that knows what type of model is being passed into it. I can say that the model I'm passing in is a department. Actually, it's a list of departments. So please scaffold out a view for me that uses my default layout page that would display a list of departments. And if I click add, I'll get some HTML markup and Razor instructions to dump out a list of departments. Here's a for each item in that model. Give me a display for the item name, and then provide some links. I'll hit Control F5 to run. With structure map in place and our SQL Server set up, we'll hopefully get a quick list of departments. And there's our departments: engineering, sales, shipping, and human resources. So I scaffolded that view out. You don't need to use scaffolding, and you can always come in here and modify things. In fact, let me just start this over. I want the title of this page to be all departments. And in fact, I will have an H1 tag here that outputs viewbag.title. And I can do that with one of the Razor C# expressions just by including at the front. And then I'm going to create an unordered list of these departments instead of a table, which is what the scaffolded code gave me. And I can say for each department in the model, there's a model directive at the top of this view that tells Razor exactly what type of model should be passed into it. So it should be expecting an IEnumerable of department. That means I can loop through the model and get a department out for each object. For each object, I'll create a list item that just has the department.name. Let's save that and see what this looks like. And there we have all departments again: engineering, sales, shipping, and human resources. To review what we've seen so far, we have created a new MVC4 internet application, and I showed you how routes take requests from a browser and send them to a controller. Here we are requesting /home/index, and that goes to the index method on the home controller here inside of my application. It's a simple naming convention. The home controller ultimately uses a class derived from dbContext, which is a part of the entity framework, to talk to SQL Server. The controller doesn't know we're talking to a dbContext derived class, though, thanks to the constructor here. The only thing we know about is an iDepartment data source inside of the controller. Behind the scenes, there is the entity framework, which we not only use to access the database, but we also use the entity framework migrations in the entity framework version 5 to create our database. You can see the controller uses the iDepartment data source to grab all the departments. It hands off the departments to the view to use by passing the departments into the view method. The view we are using is the index view. That's the default view for the index action. And this view takes the model and creates HTML. Using some C# code, we loop through the model and write out the department names. If you want more details on controllers and views and Razor syntax, my MVC3 courses go into much greater detail, and everything I cover in those courses is applicable to MVC4. In the next module, we'll continue with this demo by adding more controllers, more views. We'll We'll see how to create links in our views, how to edit and update data and perform data validation. We'll also authenticate users and then deploy our application to the internet, but not just the internet, to the cloud.